The topic for today is integrating Gen AI into modern software solutions. And I'm sure that you must have heard about AI and Gen AI multiple times over the last several months, as well as in the conference itself, right? So what we're going to do today is we'll try to dig deeper into broader software development lifecycle. And we'll look into what are the different opportunities that we have from the point of view Gen AI, how you can integrate that, and what are the challenges that you might encounter, and what are the ways to tackle them. So with that, I think there is already a lot of introduction being shared, but just wanted to hear from the group, how many of developers are here? Raise your hand. Okay. How many architects? And you can play a dual role as well, that's fine. Okay. Anybody from QA, testing? Okay. All right. How many product managers? Okay, there are a few. All right. So we do have a good mix. So let's put the logistics out of the way. So if you don't have to take a screenshot or take a photo, you can just look into this QR code. All of the session slide is available here. And if you want to connect over LinkedIn, just use the another QR code. Please do add a note, that would be helpful. So I might give maybe 10 seconds. All right. Hope it's done. All right. So in terms of key takeaways, we'll start with what are the broader opportunities of using and leveraging Gen AI in the software development lifecycle. And we'll also talk about some of the architectural considerations that how do you integrate these Gen AI tooling as well as techniques within your own ecosystem, within your own organization. We'll look into why do you want to optimize or even fine-tune these models, especially for software solutions. And then we'll also talk about some of the challenges and solutions, which I have seen across multiple implementation that we have done in a similar area. And then towards the end, I'll talk about some of the future trends that is happening as of now, as well as how this field is shaping up. And what are the areas that all of us need to make sure that we are learning about those. So starting with generative AI in software development, as all of us know, the Gen AI is already transforming enterprises through many ways. The reason we use the word generative because it is being used to either generate content. So I'm sure that all of you have used and tested with Midjourney and maybe even ChatGPT and try out recipes or pasta recipes and whatnot and creating fancy images. But it can also be used to generate softwares, and that's what going to be the focus for today. But then you also have an option of generating interfaces, and those could be, instead of a same interface giving to everyone, how you can have an interface which is created on the fly for every individual and their persona and their requirements. And then we also have generative robots, which is nothing but how these machines can accomplish some specific tasks using various generative models. As we all know, the Gen AI is already rapidly changing the way we do the work, the way do we create. And the idea is it is allowing us to produce more, but in the less time. But that also means that enterprises need to adapt and embrace these AI and Gen AI to stay relevant and also thrive. And you might have heard many of the organizations, companies, startups, they almost went out of the business after many of these tools came up. So if you look into today, and in the context of software, because this conference is all about developer conference, so I'll talk about more in the context of software. We are looking into opportunities where how do we reduce the cost and time to develop the software, and most of the conversation that you will hear today, as well as all of the different sessions, related sessions in this event is going to talk about this. And then that means is more and more demand is also there. So a lot of people are looking for, can you create these sophisticated, interesting software? So volume is definitely increasing. But at the same time, it's very hard to find these skills. And that could be a roadblock, like we are talking about full stack developers, and we are talking about somebody who can build these systems end to end pretty fast. That's definitely a challenge, and that's the reason you find lot of booths like looking for people, and they want you to join the organization. And then you look into the economics of these total cost of software development, and ownership is getting disrupted. What used to be multi-months approach and projects, now people are, and the organizations and our clients are expecting things to happen in a matter of days. But it's important, while this is all about today, let's also need to focus on what is going to happen in tomorrow world, where we are expecting the software development is going to be on demand, where somebody will look for, hey, I have to build a solution, and then you have a mechanism that will spit out the software for you. In fact, there are a bunch of reports where we're talking about text to product. We have heard about text to image, we have heard about text to code. Now we're talking about text to product, which is somebody is defining what that product that they want, and the output of that would be actually the entire full-blown product. So we are already getting into that world, and we'll touch upon on those. But while we go ahead in this, it's important that we look into the broader, what we call as a software development lifecycle. Because at the end of the day, any software development goes through different journeys. And you might have seen these infinity curves, right, where it goes through different stages. And comes in all shape and form. Sometimes it's also a circle, right? But all in all, if you look into these SDLC lifecycle and opportunities do we have, there are primarily 4 buckets. The first one is ideation, which is what do we want to build at the first place? What's the concept? And if you look at from a time spent perspective, roughly around 5 to 10% goes into this activity. And then we have planning, which is, okay, now you got an idea, I have to build, but how do I plan? What are the activities? What are the requirements? Can I do wireframing and prototyping? All of those initial planning that we do. And then you get into the actual build, which is the lion's share of the time that it takes, 40 to 60%. And then once you have built your software, developed those, the next step is all about operating those, which is how do you deploy that? How do you build your continuous pipeline? How do you make sure that you are testing it enough? And how do you manage the life cycle of your software? And maybe eventually retire that application as well. So that's also a considerable effort, almost like 25 to 35%. So what we are going to do today is we are going to dig deeper into each of these stages and identify what are the opportunities that we have from the perspective of GenAI. So if you start from the ideation phase, and this is very like a great example where you can use tools like ChatGPT. I'm sure that if you are a startup or if you are any product development, you might have asked ChatGPT or any related tool for certain ideas. So you can have your prompt, and that's where your prompt engineering skills will come handy. We say, hey, you know what are the different software product ideas can you recommend for this specific persona and this specific use case? So you can fill in the blank, and in a matter of seconds, you will have tens and hundreds of those ideas. Obviously, you'll have to filter them. Or you can say, you know what, my primary target audience is suddenly became X, right? Maybe it's a shifting demography, right? So how do you look into your product and services offering, and what are changes that you would do? And hence, there is a set of recommendation and development has to happen. So this is all about how do you bring GenAI tools in the ideation phase. And the idea is that these techniques and these prompt and GenAI models can help to do a lot of disruptive thinking, right? So it can give you like challenge the status quo and say, okay, the world is changing. What are the new things that I can do, and what are the new softwares and features and applications that I have to build? It can also bring what you call as a diversified brainstorming, which is, imagine this as a virtual member in your brainstorming team, and then you are providing different bunch of spontaneous suggestions and back and forth. Obviously, these tools are pretty good in rapid idea generation. So it can generate bunch of different ideas for you. All you have to do is provide appropriate prompts and a series of challenges and prompts. And then it can also do a lot of trend synthesis, right? It can look into the ever-changing landscape on the technology side, on society, on regulations, and then help innovators to understand this and provide, again, generate certain ideas. or scenario explanation, which is, hey, here are the few things which are going to change. In view of that, what are the software ideas that we need to build? So this is all around ideation, and you see that there are a bunch of tools. I'm sure many of these tools you might have already used. So ChatGPT is one, Gemini, you can use it. Microsoft offering on Copilot, you can also have a conversation and a chat with that. Anthropic has Claude and all of the different Claude Opus and different models available. So this is around ideation. Let's switch to gears and go to the second stage, which is around planning. So now you got an idea. This is what I want to build, but how do I plan? And that's also a big area where you can use GenAI in different shape and form. If you are a product manager or a project manager, you can actually use many of these tools to write user stories. All you have to do is just ask relevant prompt, which is, hey, I have this problem statement. Can you write user stories for you? And it will give you all of those user stories as a user, as a different actors. So this is just one of those applications. Or you can use it for wireframing, which is, okay, I have maybe I may not be good into, let's say, Figma, but maybe I don't need to be. All I have to do is go and put text in terms of what I want and what kind of a wireframes that you want. And there are a bunch of plugins, there are a bunch of tools which are available which can give you this low fidelity wireframes. But why only low fidelity wireframes when you can actually go to the complete high fidelity design itself? So again, there are a bunch of Figma plugins. The other tool which Visually AI, where you don't even have to have a wireframe. All you have to do is just sketch and then just take a snap and then upload, and it will give you a full high fidelity, the design, what it might look like. In fact, it can take it to the next level. It can also give you the HTML and all of that code base. So these are another big area where a lot of GenAI tools are being used. The next one is around synthetic data generation, because many a times there are great ideas, but one of the big hindrance that comes is, hey, I don't have the data to even start with. So in those areas where what you can do is you can leverage again these large language models, which are really good in terms of creating these synthetic data. All you have to do is imagine the contract, imagine that what's the query, what is the structure of your database, right? You can provide the schema information, and then what these large language models can do is they can understand the relationship, whatever the tables, it could be one table, it could be multiple tables, it can do all sorts of things, and then give you a raw synthetic data generation. What you can do is you can further apply some more refinement and more filtering. So, and there are again some tools I have mentioned here is Grittle AI, which does exactly the same. In fact, you can write your own code if you are a developer. You can use any of the large language model as a base and an API, and then create pretty interesting prompt. And then maybe it's a few short learning, which is provide you enough examples of those schema, and then it will create a JSON file for you. It will create a CSV file for you. All of that can be done. So we saw examples around ideation and planning. Let's go to the next one, which is, I guess, majority of the folks are typically interested in, which is around building. Okay, now I have an idea. Now I know how to, I need to proceed. All of the planning is being done. Let's get into the actual build. So here again, you have multiple opportunities of leveraging GenAI. So let's look into some of those examples. So what you can do is, you can start with code search. Very primitive example, but very powerful. Imagine that somebody is joining your team, a new developer, and we are doing an onboarding. One of the biggest challenge it comes is, especially in a bigger project, is how do you get a KT, right? How do you understand what's happening? And how do you see the code on demand? So if you have worked on what you call as a chat on your data kind of an application before, which is nothing but something called as retrieval augmented generation, where you can ask for whatever the data that you're looking for as a query, and in the back end it will filter and do a re-ranking. All of that happens. You can apply the same logic and philosophy even in the world of code. So here is an example. For example, you start with, here is my knowledge base. what I can do is I can do what we call as a chunking, which is slicing your code in a specific fashion. Because unlike the text, right, where you can just slice on paragraphs, in a case of code, they follow very specific pattern. Right? So, for example, if you're using any kind of a language, if you're using Python, if you're using Java, you have to make sure that you are understanding the syntax and then applying those syntax-aware chunking methodology. And once you have done that, what you can do is you can apply something called as embedding model, which is nothing but imagine how you can take anything, right, and convert into numbers. Because at the end of the day, machines can only work on numbers. So what you do is you take these smaller chunks, you take any of these embedding model and dump into some kind of a database. So obviously with the GenAI, the newer types of databases have also emerged, which is one of the popular ones, like in vector database is a big family. You might have heard about VV8 and Pinecone, and then lately all of the more traditional database providers like Postgre and others, they've also came up with their own vector database version. And once you have your representation here in the vector database, what you can do is somebody is asking a question, you can go ahead and go to query. You get the embedding of the query itself, which is nothing but a number representation of your question, and go and search within this massive space around which block has similar content to my query. And once it finds out, okay, this is the region and these are the set of chunks which are most similar, then it comes back and then it again sends that data to another large language model. And we are telling, hey, as a large language model, you understand the syntax, you understand language, you understand everything. I am providing you additional context, which in this case, your own piece of code. And that's where it generates the final response. So this is a very popular example, what we call as a RAG, or a retrieval augmented generation, so which you can use it for building these code search. The second application and the bigger bucket of family of use cases and applications are code generation, which is, I'm sure many of you have already played with different models, like whether you can ask for in ChatGPT, you can ask in Gemini or Copilot, or GitHub has GitHub Copilot, and there are a bunch of other things like CodeGPT, AWS has a solution, and many of these power is already integrated with your IDEs. So if you're a VS Code fan, if you are a JetBrains and IntelliJ fan, so many of these plugins are available which you can use. And you can do it multiple things. You can use it for code completion, which is all I have to do is just type my function name, and then it will automatically give you the entire code block, right? That's one. You can use it for code explanation. The worst thing that can happen is to see others' code, right? Yeah, I typically prefer to write my own instead of reading somebody else, right? So, but if you have to do that, because that's part of your job, you may want to understand what somebody had actually done. So for that, you can use features like code explanation, where you can select a piece of code and ask your plugin to say, can you explain what's going on? And the LLMs will actually do that job for you. Or you can do code refactoring, because I have written some code, but I want to see a refactored version of that. And many a times your leads might be asking, hey, your code is not refactored enough. Maybe it's an opportunity for you to leverage some of these tools to do it much faster. Or documentation. I know everybody hates to write documentation, but ideally it is definitely not a great practice though. So it's again a lot of repetitive and mundane tasks you can offload to these GenAI tools. So you can do a documentation, you can use it for writing test cases. So you can just select your code and say, you know what, can you write a unit test for me? You can do that. In fact, you can ask for code review and ask for bug fixes. And select the code and say, hey, can you look into what's wrong in my code? And then it will also review the code, it will give you recommendations, and you can go ahead and apply those recommendations. So in fact, let's see some of these in action, right? So, and there are many, many tools that you can use. One of the tools that I prefer a lot, Okay, how do I share this? Okay, I need to, is it, okay, I need to drag. All right. So, so one of the tool that I like to use is something called as Code GPT. I'm not sure if that is even visible. So you can go to your extensions. This is I'm using Visual Studio Code, but feel free to use anything else also. You can just search for Code GPT. Okay, let me see if my internet is connected. Yeah. So and then from there you can. I think I have already installed, so you can look into this Code GPT. But then there are others. You can use Copilot. The reason I like Code GPT because it is very flexible. You can change and swap the underlying models that you want. And once you are here, you can have different providers. So you have providers like CodeGPT itself. You can connect with OpenAI. You can connect with Azure OpenAI. You can connect with Anthropic, Cohere, Vertex, Google. If you are running local model, you can connect with Olama, and then bunch of others. The one that I am using right now is something called as Grok. How many of you have heard and used Grok before? Anybody? Have you? Okay, awesome. So imagine that if you have used ChatGPT, and if you ask something and you, in a blazing speed, you get the response back. But then multiply that with 100 times, right? So Grok is essentially, they have created another chip. It is called as LPU, language processing unit. So we were talking about GPUs, and obviously NVIDIA is in that race. So what Grok folks have done is they have created a complete new hardware just for predictions. And they are really good at it. So you can do, in fact, you can sign up for Grok pretty easily. All you have to do is, let me see. You can just go to the Grok website and Playground. You can select API keys, and you can plug in your API keys here. So the one model that I'm using here, I'm not sure it is very visible, but it is something called as Llama 3 model, and that's a 70 billion model. So Llama 3 model is something that got released this week, I guess the last week, in the last few days, which is obviously breaking the internet, breaking all of the benchmarks, and it's already available. So once you have configured your Code GPT, you can use it for all of the different things that we just discussed. So imagine that I have a piece of code. I just copied pasted from somewhere, so it's not mine. But then I can see, okay, where is this code? Can I ask it to explain what is going on, right? So, and you can see the moment I just typed, right, I just selected, it was already going to the API, making a recommendation, and then providing the result back, which is super cool, super fast. So it does all of the explanation. All I did was just selected a piece of code and I asked it to explain. It gave you, okay, this what you're doing is you're trying to connect your MySQL database with Python. You established a connection, then you verified the connection, then you retrieved server information. You create a cursor and executed a query, right? So you got the entire explanation done. Now what you can do is you can say, okay, I have this piece of code. Can we document that, right? So let's document, because I don't like documenting much. So what it did was it created this entire documentation for you, right? It understood the context, it understood, okay, what are the variables that you're using, what are the purpose for which it is being used, and then providing all of the documentation. And all you have to do is you can click insert and it will replace your current code, right? So documentation is you saw. Let's take maybe a couple of more. Then I'm finding it hard to read what is mentioned here. Next one is refactor Code GPT, right? So you say, okay, my code is okay, but can I make it better, right? So let's ask it to refactor, right? And then here you have a refactor. So here is my original piece of code, and then what it did was it created another set of function. It extracted it out, made it more generic, and then refactored the entire thing, and then called into the main function. All just few seconds, all right? Maybe you can ask it to create unit tests, right? So let's write tests for it, right? It already wrote me at least 5 test cases, right? So which is, okay, here is my code. Can you write all of this unit tests? And then you can go ahead and use that. So this is just, we're looking into just few of the examples. You can take it to the next notch, actually. So for example, now you have all of this code done. Now you can say, hey, can I Dockerize this, right? So Dockerize the code, and I don't even know whether it's the spelling. Is it Dockerize is what written? Even I can't see. It's pretty hard for me to read. All right, let's test it out. Okay, so what it did was I selected a piece of code and say, okay, now you have to deploy. So can you create a containerized application? So it gave me an entire Docker file that here is how you can write that. Here are the different requirements. Here are different files that you have to create. It will give you the entire structure. And then you can, in fact, create a Docker compose. You can do all of that. If you are an infra person, you can say, write the Terraform script to deploy on GKE, right? So now it will go and, in fact, give you the entire Terraform code, which is now you can take this code and deploy it on Google Cloud or any of the container or Kubernetes cluster, right? So these are just few of the examples that we saw, right? You can do lot of many things. So these are just some of the, I would say, relatively easier problem statement. The reason I'm saying because these the current models are really good into doing all of these activities. Though there are certain advanced use cases, one of the advanced use cases code optimization, which is how do you polish your code, which is, okay, I have written a code, and if you have done lead code or any of those, right, it gives you what is my time and space complexity. But I have written some code. Can I ask large language models and GenAI tools to rewrite that, but much more efficient? So there are a lot of work happening, and right now, many of the organizations are building their own code optimization tools. I'm sure it will come inside many of the current IDE plugin as well. In some shape and form, it's already there. But what you can do is it can look into the current code. It will look into, okay, what is the time and space complexity and the memory requirement, and then it will optimize that code for those KPIs. The other one is code translation. And you can use code translation, which is already available, in fact, in many of the current packages and the tools. You can say, okay, here's my source language, and I want to translate into a destination language. Many times you might have heard about, hey, I have a legacy code, and I want to move it to probably new gen code. So you can leverage these GenAI tools, which will just point it to your legacy code. It will do all of the transformation and convert into the newer version of the code. It's not a very easy problem, just to be very clear. And even the current generation of models, they do flunk, right? While on the smaller code snippets, they do really well. But in a real world project, if you look into the success metric, is still abysmally low, right? Roughly 8 to 10%, because real world projects are much more messed up. But if you look into, and then there are a lot of benchmarks are available. So one of the benchmark is something called as code editor bench, which looks into the different activities. For example, how good a model is in terms of a code translation, which is taking from a language 1 to language B, we just saw. And they are using a metric, something called as pass at 1. What is pass at 1? Means if you have generated some code, that code should work, right, for the first time without touching that, right? So that's where it called as pass and 1. And pass and 1 score for many of the models on some data sets were really good. Some models are not that great. Then there is a activity, something called as code requirement switch. Imagine that the code was written for some other purpose, but my purpose has now changed. Can I just ask these GenAI tool to say, hey, you know what, my purpose has changed. Can you recreate the entire code base for a newer purpose? That's called as code requirement switch. So you can do that also. Obviously, this is not a great, still you can see the scores are not great, but a lot of work happening in this space. Code polish, we already saw, which is how do you optimize your code for better execution time and better memory footprint, and code debugging, right? So which is how do you debug the code, how do you understand where are the issues. So these are all activities we saw under the build phase, if you recall the SDLC lifecycle. And you can start using many of these tools which is already out there and see what works in your context, what doesn't work in your context. And then let's look into the last phase, which is an operate. So now you have got your code done. Now you have to deploy that, you have to manage it, you have to monitor these systems. So there are, again, a lot of applications. We already saw a couple of examples around how you can take a piece of code and just deploy that by containerizing that application, writing the infrastructure as code, like Terraform code, and deploying in Kubernetes cluster on Google Cloud. All of that is just a matter of a few prompts. But then you can use it for pipeline automation. Imagine that you have a massive Jenkins pipeline, bunch of activities going on. You can use GenAI tools for that. You can use these for anomaly detection, which is these AI systems are really good into what you call as finding the needle in the haystack, which is there are a lot of data points going on. How do you identify if something is anomalous in nature? So these systems can actually traverse through a vast amount and vast array of data and identify what is wrong and give you recommendation, give you root cause. You can use it for infrastructure optimization, and you can use it for your adaptive problem resolution. So imagine somebody is creating a Jira ticket for some issue, and then it automatically gives you a recommendation, which is, hey, what might be the issue behind that? Here is the set of recommendations, and what you can go beyond this. And in fact, in our own organization, we have been bringing many of these tooling as well as building a lot of bespoke layers and components because we do run like hundreds of these projects. And here is a quick snapshot of what we have seen already with a bunch of teams. And we are already looking at what you call as a reduction in time from idea to life is 20 to 40%. There are certain stages where we are seeing more what you call as bang for the buck, like for testing, which earlier used to be a lot of manual activities. We are seeing reduction in time significantly. Similarly in the build phase, similarly in the deploy and support phase. This is based on, like, we have run like over 100 experiments. In fact, we built a lot of tooling around your initial concepting. We created something called as backlog AI. We created our own what we call as ChatGPT equivalent. We created a lot of fine-tuned model, had end-to-end pipeline. We created test suites powered by GenAI, right? And now we are using these. Oops. Sorry. That's what happens when you are too much animated. All right. So yeah, so this is just a few examples of how these are not just theory, right? We are already seeing the value of bringing these tools into the ecosystem. So hope now you are convinced that there is a lot of opportunity of GenAI in the software development lifecycle. Let's talk about some of the architectural considerations. And as you're thinking of bringing these GenAI tools within your own organization. So if you look at how currently developers integrate with the GenAI model. So you have on one side developers, on another side you have the GenAI model. Ideally, typically developers won't directly interact with the GenAI model. Rather, they might interact with a layer on top of it, maybe an API which is being given. Maybe you might have heard about or used OpenAI API or Azure OpenAI API or Gemini API. So developers, what will do is they will interact with this API, give the prompt, and then you will get the response back. That's how typical interaction is going to happen. And the model itself could come from training data. Imagine the entire GitHub repos that is being used to train these models. And so that's one option, so which is similar to your ChatGPT. If you have played with that, asked for a code, which is nothing but you're going directly in the interface, going through the API, and then in the backend, it uses the large language model to respond back. The other option could also be is that you have a code editor in between. So developers are using the code editor. For example, in this case, I was using Visual Studio Code, and then Visual Studio Code was in turn creating the prompt. For example, when I say explain this code, what happened was it created this entire prompt, which is, hey, here is my activity, here is my context, and then passed to the API, and then you get the response back, and then finally it comes to the developers. So that is another way of the interaction. But let's look into what are the different considerations and challenges that are there. The first one is around latency. The worst thing can happen is that you have asked your team, hey, go ahead and use these GenAI tools, and they have said, hey, explain my code, and then it took them, I don't know, 10 minutes, 20 minutes. They went for a coffee break and then came, then also your API response was not done. Obviously, you don't want, right? I'm taking an extreme scenario, but the idea is if you're doing a coding and development where you require things to run very fast. So you need to make sure that whatever the systems that you're putting, either you're using these commercial solutions like OpenAI or others, Copilot and others, or if you're managing your own infra, right? So you have to make sure that latency is is appropriate as per the requirement. Sometimes you may have to look into your subscription level quota if you are actually a leader who is responsible for bringing these tools. Many times there is a quota which is mentioned at the subscription level, so you may have to manage that. Sometimes you have to have these SLA agreements with the provider done to make sure it is as per your requirement. You might have to switch to a smaller model. So while we are talking about GPT-4, but maybe for many of your tasks, you don't need bigger model. Maybe smaller model is good enough because that also give you a saving as well as it will be much faster. Or you can use something called as LPU. We just saw an example of Grok LPU. I showcased that on VS Code, which is your language processing unit. So you can use service provider like that, or you manage your own infra, you manage your own SLA, you deploy your own model, and where if you, based on a requirement, you spin up maybe tens and hundreds of GPUs, if you have money to manage that. The other big consideration is around data privacy. We saw that these API being used. So whenever you're using an API, you are sending something to an API. So there is a data that is being transferred over the wire. So that means is that there can be a risk, and you might have heard news which some developer actually looked into very proprietary code and sent a secret to that external API. That could be a big risk. Imagine like the lawsuits coming your way. So obviously you have to manage all of these data privacy considerations. So make sure that you are checking all of the fine prints you are looking into before you subscribe to any solution, before you subscribe to any API, what is written, how your data is being used, whether it is being used for training or not being used for training, whether there would be a zero data retention, which is once you have used and all of your data and signals will be purged, or how it is according to the regulations and compliance, especially if you're working in highly regulated sectors like financial services or healthcare. They have a very specific regulation in terms of what data you can send and what data you cannot send. So you have to look from a GDPR, you have HIPAA, you have CCPA. So there are a bunch of different regulations that you have to adhere to. Or you may have to manage your own LLMs. If you are so scared, I know I talk to many of the leaders in financial services world, they're still hesitant to bring these solutions because they feel something is going over the wire to some other party. So in those scenarios, maybe you want to host your own large language models within your own security parameters, within your own infrastructure. That could be another option. Then from other security perspective, we saw this diagram, right, which is how the data flows between developers. Imagine that if somebody is hacking the system. So you suppose a hacker looked into the training data and actually made manipulations. So if the data is wrong, what is going to happen? Your algorithms will take those wrong data, biased data, and that will go into the model. So model itself is corrupted. If model is corrupted, that means is the prompt, and somebody can actually intercept the prompt. And you might have heard about man in the middle attack, right? So there are a bunch of attacks can happen. And then the response would be faulty. And the developers, what they end up getting could also be wrong. So as an organization, if you're bringing these GenAI tools, you have to manage these security considerations. It's all about managing maybe encryption. Maybe you put encryption at rest around the data which is being used for training these models. You use the encryption in motion, because if you're using these APIs, maybe you're using your TLS and mutual TLS things. You have to manage your access control, who has access to what, to make sure that you have the appropriate controls. And then you have appropriate input and output guardrails. So when you say input guardrails, if somebody is using, let's say, any of the GenAI tool and somebody punched in their own, what we call as a PII information, personal identifiable information about their name and their address and their phone number, how do you make sure you detect that, you know what, my API, it should not take those input data? Or the output guardrail, imagine that you're using the GenAI tool and started spitting out cuss words and toxic language. You don't want to do that. So you have to detect those output as well. And then the other big one, which is copyright consideration. So yes, these tools will give you the code, and we saw a bunch of examples. But actually, who owns the code? The code that got generated, who owns that? How many of you think that it should be owned by the training data owner, the team who actually had, or the organization who had the actual data? Okay, we have one. Anybody else in this bucket? Okay, we have a couple of hand raised. Let's see. Okay, how many of you think that the GenAI model creator, the team who actually took the data and trained the model, they should own the code? Okay, but imagine that if they are two different entities, right? So they had, the data was not theirs. They just took the data and then trained the model. Okay, how many of you think that the prompt user, the person who actually wrote and made the effort to write the prompt and to generate the output, that person owns the code? Okay. And how many of you think that the model itself actually owns the code? No individual, the machine. Yeah, we have a couple of hand raised. And the answer is, we don't know yet. That's the fact of the matter, right? So you will find that the legal regulations and others are still, is not meant for these kind of generated content. Because it's not copy paste. It's not that you're just copying and pasting. Maybe yes, many a times you might get the similar code, but it's not a direct copy paste. There is, and also there is what you call as a word by word or token by token, the things are appearing. How do you know which is coming from which source? It's very difficult. So again, so the lot of laws are coming, even the legal folks, lawyers are, I don't know, they are confused. How do you even address it? Well, while all of these are happening, if you are bringing these GenAI tools and if you are using these GenAI tools within your own organization, it's important to understand these considerations around intellectual property, IP. Right? So make sure that you look into what was the training data was used to train these models. So for example, GitHub Copilot, they took everything which was there in GitHub and they trained the model. As you can imagine that, no, it didn't go and ask every individual to, hey, here is my consent. They didn't ask for it. They just went ahead and did that. Do you think it's right? Maybe not, right? There are some, for example, Tab9 is another provider. They said, we only looked into and scraped data which had the permissible license. Right? So there are a lot of license types you might have seen. Adobe, you have your GPL license, BSD license, BSD v3, GPL v3. So there are a bunch of different types of license. So Tab9 folks, they said, okay, we are going to use something which is, there is a permission already available. Explicit permission was not needed. So you have to check, make sure that the model that you're using, what data was used. And what is the impact of using the generated code within this? For example, imagine you have a proprietary code base and your team member used any of the GenAI tool and created one piece of code. And that piece of code is coming from these models, open source models. So now you took that piece of code and brought into your proprietary ecosystem. As per the legal thing, the entire thing has to be open source now. right? So there is a lot of legal hustle, and hence it's important to involve the legal teams as you're getting into this journey, right? Not many of you might not have to worry about that, but I'm just sharing, right? It's important. Then it comes to the personalization consideration, which is, okay, I got these tools, but unfortunately the results are not predictable. Sometimes it works, and I showcase the best possible example and demos, but I'm sure that as you will try, many of times it won't work. Or the prompt length is limited. So maybe all of these models, they have a limitation around 4,000, 10,000, you have 16K model, now you're coming with 128K model. So, but still there are limitations. Or the model response quality is not adequate. For example, you're writing a code, but then you say, you know what, my team follows a very specific convention, but I am getting some generic output. Maybe it's not good use for me, right? So how do I sort that out? Or if you have a specific problem statement that you want to work, and I want to write a prompt or use these prompt engineering things, but how do I articulate that task? Writing the prompt and writing English is also not straightforward, right? So how do you write that? So that's where we'll look into the need. We already saw the need, which is how do you fine tune these GenAI models for your own ecosystem, for your own purpose. So fine tuning a process, I'll not go into the detail, but very high level. What you do is you start with a base model. Imagine this is a network. So this is basically a neural network model where a bunch of connections happening. So the number of connections, essentially, you might have heard 10 billion model and 1 trillion model or something like that, which is nothing but number of connections. Bigger the connection, number of connections, imagine that understands more complexity. That's how you can draw a parallel. So what you do is you have to fine tune for your own purpose, so that you have a very specific task. You have your own coding standard. You follow your own specific guidelines. So what you do is you take your own task data set, and then you take your base model, and then you train that to come up with the fine-tuned model. One option is you go ahead and change everything which is there, all the connections. But as you can imagine, if this is a million and a billion parameter model, it might take a lot of time, lot of money for running even one single experiment. So that's where, imagine, suppose that you have to do it for multiple tasks, right? So you have to create for one task, for another task, and suddenly your cloud bill or whatever infrastructure bill is running in millions. So the option is what you call as parameter efficient fine tuning. This is another approach for building something called as adapters, which is instead of training the entire thing, changing every color, what you see here, can I just look into 1% and just understand? Imagine something called as you have a cable and it's a USB-C adapter, right? USB-C, and then I have my mobile is using a Thunderbolt. So I don't have to invent the entire charger and all of that. All I have to do is create an adapter. So this is called as an adapter pattern. You create bunch of adapters, and in the process, you don't have to make a lot of changes. You have to just focus on a very small subset. And what you can do is there are a bunch of different techniques where you can create adapters. Maybe there is an adapter for one task, there is an adapter for another task, and at the runtime, you bring that adapter in. So what you do is you keep bunch of adapters handy, and then just swap these adapters whenever your requirement comes in. So imagine this is adapter for a team one. A team one follows one specific standard. They have a specific task. There is a team two. They follow specific guidelines. And what you do is the system, right? They just swap between different adapters. And in fact, if you're using these techniques, that can give you almost 98% cost saving, right? So in fact, nowadays you can like fine tune your model less than $100, right? It depends. And there are a bunch of frameworks. One of my personal favorite is Unsloth, where you can fine tune many of these models much, much faster. There are a bunch of scripts available. All you have to do is point to your data set, and it will do all of the heavy lifting for you. So in terms of challenges and solutions, okay, now you got, I like these GenAI tools. How do I deploy it? How do I start to use it? You saw the plugins and the IDE. One obviously option is that you go and subscribe to these API providers, pay money, and then it will give you. The other option is maybe start using local models. Maybe I don't need APIs. I run everything locally. And one of the popular framework of using it, it's called as Ollama. So Ollama, very simple. You can install Ollama. You can run Ollama pull, the model. In fact, the Llama 3, which was there in the last week, you can run that. And you can, once you are running that, it will give you an open AI equivalent spec, right? API contract. And you can integrate with any of these systems. So for example, let me quickly show you. So I have, if it is visible, let's see. In the bottom, I am running, let's see if I can. Right, so I have these models running. Ollama run Llama 3 8 billion, the model that came, I think, last week, right? So all you have to do is just run that. It runs as a Docker kind of a thing. It's not exactly the same, but yes. And then you can ask questions and you can integrate with, in fact, your tool. So for example, here my code plugin is currently set for autocomplete to this Llama 8 billion instruct model, right, which I'm running here on my local. So I don't have to connect to any API. I don't have to pay. All you have to do is download locally, run locally, work locally. No data is going out. That could be one way, right? You'll be safe, right? And these models are not bad, right? I can tell you, right? These models are pretty good. So that's just show that, okay, how you can use these local models. That's one option. Obviously, while this is great for local development, but for any serious business, they may want to have their own and manage their own self-hosted LLMs beyond the commercial solutions. So there are again bunch of frameworks. The one is their TGI, which is by Hugging Face. Hope all of you have heard about Hugging Face. All of the models are hosted there. The one that I personally like is something called as VLLM, right? So which gives you a low latency, high throughput mechanism. Then there is something called as Preda-based Lorax. What it allows you to swap adapters. You can have hundreds of adapters and swap those adapters on the fly, right? So you can use it for different purpose. These models provide you streaming support, multi-GPUs, high throughput, all of that. Good. So you saw, okay, how you deploy your model, how do you use these models. Now, towards the end, as we are closing in, I want to share 3 key trends in terms of the GenAI in the world of SDLC. The first trend, and you already saw a couple of examples, which is the open source models are becoming better every single passing day. So while everything, the chat GPT happened and people were jumped upon like GPTs of the world, which is great, but those are closed source systems. And with all of the open source work happening, and these models are pretty darn great, right? So Code Llama is almost at par with many of these other closed source models. And Llama 3, for example, it got released, which is claiming to be better than or at par with GPT-4. The second trend is smaller models. While we are talking about large language models, the world is moving towards small language model also, right? Which is instead of having a massive 10 billion, 70 billion model, can you have a very small footprint of the model? So for example, the latest one that came last week, Llama 3, 8 billion model is almost at par with the previous model, which used to run on like bunch of GPUs, 70 billion model. Or the model that got released 12 hours back, in fact, I had to make those adjustments. Microsoft launched something called as 5.3. And that model, in fact, you can bring that on your own mobile phone, right? And you can use that. Imagine that you can run all of that locally. And that model, for example, medium size model is almost at par with GPT 3.5, which was there earlier. So that's your second trend. The third trend, which is critical, which is agentic world. The world is moving towards agents. We're not talking about Agent Smith, right? Anybody here, the Matrix fan? But agent is nothing but imagine a system which has its own memory, which can do a lot of planning, and it has access to a lot of tools. What it can do is it can take a request and do certain activities. So imagine, so you can have an agent for doing development, and you have an agent for doing QA. You have an agent for writing stories. And so while you can have separate agents, what you can also do is multi-agent collaboration. where you can identify what is my standard operating procedures and then how these agents are going to interact. In fact, it is already there where you can just ask what you want to build. First, it will assume a role of a CEO. It will define the idea. It will assume a role of a CTO. It will define how the entire blueprint would be. It will assume a role of a programmer. It will develop things. It will assume a role of QA, and it will QA things. It will assume a role of the deployment person, and it will deploy. All you have to do is ask what you want, go and grab a coffee, maybe, and go chit chat, and then come back. Right? So we are already moving towards this world. Right? So if you have seen, there are frameworks if you want to build these systems, something called as Crew AI, AutoGen, LangGraph. How many of you have seen this Devin AI video, right? Yeah, this is already going towards that agent, the world's first AI software engineer, which can do a lot of things automatically, connected to the pull request. It will understand the code, it will understand the challenges, solve that, write the code for you, unit tests. Similarly, then there is an open source version came, Devika, which is the AI software engineer created. The one, if you want to experiment, I tried running Devika. I ran into a lot of issues, but OpenDevin works really well for me. It's one of the most trending project right now. Within, I guess, 15 days, it has 22,000 stars on GitHub. So feel free to try that. Microsoft is launching and bringing all of these systems, something called as AutoDev, where again, bunch of agents working together. So if you summarize, hopefully all of you got a feeling of what it can do for you, right? If you are remotely associated with software development, make sure that you're also staying realistic. While AI is great, it is not a solution to every single problem. So don't rush into shiny things, but it's important to experiment, and hence be agile. Have a human in the loop, right? So while AI promises this massive automation, but having this human oversight is needed. So if your code review is not going away, right? Making sure that there are policy and guidelines in places so that you can use these things appropriately in a managed risk environment, and drive adoption by starting small, right? So do one thing, share that experience, celebrate those success, and create that snowball effect. All it takes is a couple of success stories, and then everybody will start using it. But be careful when sharing the data. Know how the fine prints. Remember, right? We are all developers. We are all geeks, right? So our purpose is not only to build shiny things. Our purpose is actually to deliver the faster value. And GenAI holds a tremendous potential in doing that. So an AI, I don't think so it is going to replace you, right? Still not yet. But somebody using an AI will definitely do that. So make sure that all of these toolings are there in your repertoire. Start using it. Learn, unlearn, relearn, and stay relevant. Thank you.